So part 2, it's continuing just doing solving equations for x. And in number 10, both the 4 and the 8 are going to need prime factor trees, and they already have exponents. So I'm going to put both sides with a parentheses. The 4 I'm going to replace with 2 squared. The 8 I'm going to replace with 2 cubed. Now I'm going to clear the parentheses by multiplying the exponents. On the left-hand side, 2 times x and 2 times 2. So the left side will give me a 2x plus 4. The right-hand side, clear the parentheses by multiplying the 3 times x. Once I get the exponent, the bases to be equal, I set the exponents equal to each other and I drop the base. And the easiest way to solve this would be to just minus 2x from both sides. And this will give me 4 equal to x for my answer. So it's not a fraction, I'm not going to check it. For 11, 49 has an exponent and it needs a prime factor tree. I'm going to give the left side a parentheses. The prime factoring for 49 is 7 squared. And on the right-hand side, the 7 has an implied exponent of 1. To get rid of the parentheses on the left-hand side, I multiply 2 times x and 2 times 3. So that gives me 7 to the 2x plus 6 equals 7 to the 1. Now I'm going to drop the 7s and set the exponents equal to each other. Do the algebra to isolate the x, which would be minusing 6 from both sides, and then dividing by 2. And I think I should get x equal negative 5 halves. I really don't have to check, especially because it told me I'm getting a fraction, but I can. If I wanted to check, I should just go to the original problem, 49 to the x plus 3 equals 7, and see if 49 to the negative 5 halves plus 3 equals 7. 49 exponent fraction negative 5 over 2. Negative 5 over 2 plus 3. And it works, it gives me 7. So this gives me 7 equals to 7. All of these can be checked, none of them have to be checked. Now just 3 more problems. They're each a word problem. And each word problem in the test will give you the formula. You don't have to have the formulas memorized. The first problem 12 uses the exponential growth formula. The future amount after t time periods is equal to the starting amount times e to the growth rate as a decimal times the time. So in problem 12, it says the population of Arizona is currently 7 million. That's going to be my p sub 0. It's going to be 7. And it's growing at a rate of 0.75% per year. The percent form of the r is 0.75%. I need to change that to a decimal, so I need to take the decimal that's given and I need to move it over 2. And when I do that, I have to add 2 zeros. So the decimal form of the r is going to be 0.0075. Because if you have a percent, to make a percent into a decimal, you drag the decimal 2 to the left. And that, in this case, makes me add 2 zeros. And then estimate the population of Arizona in 20 years. That's going to be the t. So on the left-hand side, p stands for the population of Arizona. T, in this case, is going to be 20 years, equals to the current 7 million population times e to the 0.0075 times 20. It says round to 2 decimal places. I'm going to round to 2 decimal places and tack the word million after my answer. So I'm going to go 7, shift an ln, 0.0075 times 20. And I round to 2 decimal places. And I can do that without doing any extra writing. So the population in Arizona in 20 years is be about 8.13 million people. And instead of writing a sentence that the population in Arizona in 20 years is 8.13 million people, I'm just going to do that for my answer and not write a sentence, and that's completely adequate. 13 wants me to use the compound interest formula where the A is the future amount of money, and that's what I'm solving for. The P is the starting amount of money. And that's going to be given in the problem. The R is the decimal form of the growth rate, or the decimal form of the interest rate. And the N, it depends. If it says annually, the N would be 1. If it said semi-annually, the N would be 4. If it says quarterly, well, if semi-annually, the N would be 2. Quarterly, the N would be 4. And I think that's all we did, so we don't have to worry about anything else than that on the test. And the T is usually going to be the number of years. So in this problem, as I read through it, an initial deposit of $10,000, that's going to be the P, that's the starting amount of money, earns 3%, that's going to be the R, but my R is going to need to be changed into a decimal. It's going to be 0.03 or 0.03. So 10,000 P earns 0.03 R compounded quarterly. So the N is 4. How much will be in the account after 5 years? The T is 5. So I'm going to say the future amount of money A is the starting amount of money 10,000 times 1 plus R, which is 0.03 or 0.03 over N, which is 4, to the N, which is 4, times T, which is 5 power. That's just taking the numbers and shoving them into that formula. Because it's money, I'll round to 2 decimals, even though it doesn't say that. It's just implied. And I get $11,611, and that just rounds perfectly to 84 cents. And I wouldn't even write any words. I just put a $sign for my answer. One more, and then that's it for the semester, unless you're lucky enough to take the final or have to do a makeup test. And it's the same as problem 12, except it has a negative in the formula because the amounts are going down. So the formula that's given in problem 19, it looks exactly like in problem 14, looks exactly like the formula that's given in problem 12, other than the exponent has a negative because the numbers are getting smaller. So I've given the formula it tells me to use. P sub 0 is the starting amount. R is the percent, the constant percentage that the amount's going down by. T is probably time in years. 14 talks about the population of Japan currently being 125 million people. So the P sub 0, the starting population, is 125 million. It's shrinking at a rate of 0.25% per year. So the R as a percent is 0.25%. I'm going to back up the decimal 2 and get 0.0025 for the decimal. Usually we don't start a number off with a decimal. We throw a 0 preceding that decimal. So the R is going to be 0.0025 preceded by a negative from the formula. Estimate the population in 10 years. The time is going to be 10, round to 2 decimals. So the population in Japan after 10 years can be estimated by the formula 125 million people times e to the negative 0.0025, which is the R, times 10. And then just mindlessly press buttons. 125, shift and ln, negative 0.0025 times 10. And it gives me 121.91 million people, just about 122 million people. And I don't need words. This would be completely adequate for an answer. So that's everything. If you can do all the problems on the practice test, then you should be completely fine for the test. I always make my tests as close to the practice test that I can, so there shouldn't be any surprises. Just perfect this and you should be good for the test.